Welcome to Learning with UNP. In this session of Business Intelligence with Power BI, we will learn how to create and organize a data model in Power BI using the Maven Market dataset. Before we begin creating the data model, it's essential to remove any existing relationships in the dataset. This gives us a clean slate to establish relationships according to our specific requirements. Let's see the steps to remove relationships. We are currently in Power BI desktop and we have already loaded the Maven Market dataset and made the required changes. In order to remove the relationships, let's switch to the model view by clicking on the model icon in the left sidebar. Click on Manage Relationships in the toolbar. In the Manage Relationships window, you will see a list of existing relationships like this. Select each relationship and click Delete to remove it. Once all relationships are removed, click on Close. We have successfully removed all the existing relationships. Now let's collapse all the tabs. Now let's understand the types of tables in the dataset as it is crucial for designing an effective data model. Let's classify the tables in the Maven Market dataset into dimension tables and fact tables. Dimension tables are the tables that contain descriptive information that provide context to the facts. They help categorize and group data. In the Maven Market dataset, the dimension tables are Customers table. It contains details about customers like customer ID, name, etc. Products table. It contains product details such as product ID, category, etc. Regions table. It contains geographical information like region ID, region name, etc. And Stores table. It contains store details such as store ID, store name, etc. Now let's see what are fact tables in our dataset. Fact tables are the tables that record quantitative data or events such as transactions. In the Maven Market dataset, the fact tables are Returns table. It tracks returned items such as product ID, store ID and quantity, etc. And Transactions table. It records sales transactions, example customer ID, quantity, product ID, store ID, etc. Now, in order to establish relationships, we need to identify the primary keys and foreign keys in each table. These keys are critical for linking tables. Let's start identifying primary key and foreign key in each table. First comes Customers table. Customer ID is the primary key in customer table. And let's check in which all tables customer ID is present. To see that, open this tab, search for customer ID. We do have customer ID in transactions table. Therefore, customer ID is primary key in customer table and customer ID is foreign key in transaction table as it is referenced in transaction table. Coming to products table. Product ID is a primary key in products table. Let's check in which all tables we have product ID. Search for product ID. We do have product ID in returns table and transaction table. Therefore, product ID is a primary key in products table and product ID is a foreign key in returns table and transaction table. Now, let's look at regions table. Region ID is a primary key in regions table and it has been referenced in stores table. Therefore, region ID is a foreign key in stores table. Coming to returns table. As returns table is a fact table, there are foreign keys present in returns table. The foreign keys are product ID and store ID. Now let's look at stores table. Store ID is a primary key in stores table. As you can see here, store ID has been referenced in returns table and transaction table. Therefore, store ID is a primary key in stores table and store ID is a foreign key in returns table and transaction table. Now let's look at transaction table. As transaction table is a fact table, we do have foreign keys here and the foreign keys are customer ID, product ID and store ID. Let's collapse this pane. By identifying these keys, you can correctly establish relationships between the tables. Now that we have identified primary and foreign keys, let's move on to creating relationships between tables. There are two main methods in Power BI for creating relationships. First method is drag and drop. Second method is using manage relationships option. Let's look at first method, drag and drop. Let's consider products table and returns table. Let me rearrange them. As we already know that product ID is a primary key in products table and it has been referenced in returns table. Therefore, product ID is a foreign key in returns table. So I will drag this product ID from products table and drop in products ID column in returns table. Now Power BI will detect the relationship and prompt you to confirm it. As you can see here, product ID column in both the tables has been highlighted. Click on Save. This method is fast and effective when the column names are clear and easily matched. As you can see here, Power BI automatically detected the relationship between these two tables. Now let's look at the second method using Manage Relationships. The Manage Relationships method gives you more control over relationship details such as cardinality and cross-filter direction. To implement this, click on Manage Relationships option in the toolbar. In the Manage Relationships window, click on New Relationship. In the Create Relationship dialog box, select the dimension or fact table you want to link. Let's say we link Customers table with Transaction table, as Customer ID is been referenced in Transaction table as foreign key. And automatically the common keys are highlighted. Click on Save. As you can see here, a new relationship has been established. Click Close. If you can see here, there is a relationship being established between Customers table and Transaction table. When designing a data model, fact tables should be the central focus as they contain the transactional data. To simplify the process, let's create two layouts. In order to create a new layout, click on the plus symbol here and name it as Transactions. As Transactions is one of our fact tables. We do have one more fact table, that is Returns. Click on New Layout and name it as Returns. In the transaction layout, let's place the transaction table at the center and let's connect it to Customers table, Products table and Stores table. Let's rearrange them properly. Here, let's use drag and drop method to establish relationships. We already have a relationship between transaction table and customer table. Now, let's establish a relationship between transaction table and store table. So the primary key in store table is store ID and it is a foreign key in transaction table. Therefore, I'll drag store ID from stores table and drop it in transaction table. Click on Save. In the same way, we'll do it for products table. Drag product ID column from products table and drop it on the product ID column in the transaction table. Click on Save. Now let's move on to the returns layout. Let's place the returns table at the center and let's connect it to products table and stores table. We already have a relationship between products table and returns table that we have just established. Now let's establish a relationship between stores table and returns table. As we know, store ID is the primary key in store table and it is a foreign key in returns table. So I will drag store ID from stores table and drop it on store ID column in returns table. Click on Save. By creating this layout separately, you organize the relationships clearly and avoid cluttering or confusion. Now let's move on to the all tables layout. Let's rearrange them properly in such a way that fact tables are at the center. We also need to connect regions and stores as region ID is the common key between these two tables. Let me drag region ID column from regions table and drop it on region ID column in the stores table. Click on Save. Now we have a single cohesive data model. But why is this approach effective? This approach simplifies model building process. It ensures relationships are well structured and easy to interpret. Now, understanding why we set up relationships as one-to-many is key to maintaining data integrity and ensuring accurate analysis. Let's begin with one-to-many relationship. In one-to-many relationship, one record in a dimension table relates to multiple records in a fact table. Example, one customer can have multiple transactions. Here, the customer ID in customers table is the one side and the customer ID in the transaction table is the many side. But why one-to-many? It ensures that each transaction is accurately linked to a single customer, product or store without duplication or confusion. It avoids redundancy by storing descriptive information in dimension tables and quantitative data in fact tables. It facilitates clear and straightforward data aggregation such as calculating total sales per customer or per product. By setting up one-to-many relationships, we create a scalable and efficient data model in Power BI using the Maven Market dataset. By deleting the existing relationships, identifying dimension and fact tables, and establishing a clear one-to-many relationships, you have laid a strong foundation for powerful data analysis. We must remember that a well-structured data model is essential for unlocking the full potential of your data in Power BI. This is all about today's lecture. See you in the next lecture. Thank you.